Hi, everybody. My name is Ananya Gupta. So, the topic I'm investigating in my research paper was about the noise levels in formal green spaces. Let's start off with some background information. The first thing I'd like to address is what exactly is a formal green space? To begin with, a green space is a region that has vegetation like grass, trees, and shrubs. More specifically, a formal green space is a typically human-made green space for recreational purposes. So in this image here, we see people doing yoga, kids on their bike, on the playground, so sort of that sort of recreational purpose. Why exactly do we care about green spaces? The biggest reason to why green spaces are important, specifically in cities and urban environments, is particularly because of noise pollution. Noise pollution is an unwanted or super disrupting sound that can negatively impact our physical health, mental, and overall psychological health. So here in this image, some examples of noise pollution would be like the traffic from the cars, airplane, or the train. All these can contribute to noise pollution, and green spaces are supposed to be effective in reducing noise pollution, especially in cities. The question that I was addressing in my research paper is, do noise levels within formal green spaces tend to be statistically significantly lower than noise levels outside of formal green spaces? In terms of using a statistical approach to my research paper, I had two hypotheses. I had a null hypothesis and an alternate hypothesis. The null hypothesis for my research paper was that there was no significant difference in noise levels within formal green spaces versus outside formal green spaces. It was the likelihood that the two sets of data collected had no significant difference. The alternate hypothesis was that there was a difference in noise levels within formal green spaces versus outside of formal green spaces. It was a likelihood that the two sets of data collected did have a significant difference. So basically the opposite of the null hypothesis. For my experimental design for the research paper, I used a total of 8 data sets from formal green spaces from the pool of available student data. One set was the data I had collected. 2 sets of data came from my lab group G, and the other 5 sets of data I had randomly chosen using a randomizer from Benchling lab notebooks. Then all of this data had t-tests conducted, and there were p-values that were outputted. I had compared those p-values. So what was the method of data collection? How were the students and how did I collect the data to figure out this p-value? So the way to collect the data is each one of these X's here represents sampling points. The white circle represents the formal green space, and this blue box represents this sort of outside region. So if this is the formal, this area is outside of the formal green space, and this should be like 0.25 miles at the most outside of the formal green space. All right. So 3 sampling points were collected within the formal green space, and 3 sampling points were collected outside of the green space. And it was important to make sure that these were sort of evenly spread out so it could be representative of the region that was being of the region where the data was being collected. So for each sampling point, there was a 2-minute data collection occurring, and the data collection was occurring through an app on a cellular device that can record decibel levels. This was done for each one of the 6 sampling points, and this should have been done for each of the 8 data sets. This table here shows that the p-value that was the result of each data set. Each row is the p-value for one data set, and the p-value was derived from t-tests that were conducted. The important thing to notice here is that each one of these p-values are above the value of 0.05, which will come up later in the conclusion to why that's significant. So this figure here shows the data that I had collected. This here is the mean of the noise levels for outside of the green space, and this here is the mean of levels for inside the green space. The significant thing here is that these bars are very, very close to each other quantitatively. And it shows this evident closeness of the noise levels within and outside formal green spaces, which will show why exactly the p-value is over 0.05, meaning that there was no statistically significant difference. So the suggested conclusion is that there is no significant difference in noise levels within and outside formal green spaces. What this means is that the noise levels within and outside of each formal green space are fairly similar, or in other words, not statistically significant. So we fail to reject the null hypothesis. For this study, data was collected from 8 different formal green spaces, collecting data within and outside of each green space. With the data, a t-test was conducted for each green space, comparing the mean of data from outside of the green space and the mean of data within the green space. Then there was a resulting p-value for each of the formal green spaces, which was compared to form the data analysis and the conclusion for our research paper. And the results of this paper suggest that formal green spaces are not effective in reducing noise levels when comparing noise levels within and outside formal green spaces. Thank you so much for watching my presentation. If you have any questions, please feel free to contact me here at this email.